Hey there everyone, welcome back to another video. Today we'll be looking at IGCSE ICT Chapter 1 Types and Components of Computer System. Now, when you're getting started with IGCSE ICT, this is the first chapter that you're going to encounter. And whilst you might think that, oh, this stuff is easy, hardware and software, I already know it, it is still very essential that you still learn all this and know the basics, just so that you know what to and how to answer when the question comes up. So without any further ado, let's get started. These are just the key objectives that we'll be looking at. So the main topics that we have to cover are hardware and software, types of computers and emerging technologies. The others are just subtopics under them, which we'll look at very soon. Hardware and software. Now, hardware has the most simplest definition in ICT that you can ever think of. It refers to the physical components that you can touch, or hardware are the physical components that you can touch and feel, and that make up the typical computer system. Okay, that's all. Now, these components can either be internal or external. Let me do this. Can either be internal or external. So now you see that, let's say you have a laptop, right? You see you can touch the keyboard. It's outside. So that becomes an external hardware. But when you open your laptop, okay, when you unscrew everything and you see inside, you see that you have your motherboard there, you have your graphics card there and all that. Now, this is not something you touch and use, right? So that becomes your internal hardware. So under internal, we have our motherboard. We have RAM. RAM stands for random access. Okay, so as we go, let's define each one of them as well. So motherboard, it is the printed circuit board in a computer which acts as a hub that all computer components connect to. So you have your motherboard like this. Okay, not like this, and you have all the things connected to the motherboard. Okay, then you have your RAM, which stands for random access memory. When running applications, it is internal, volatile, and temporary memory chip. So don't focus too much on RAM and ROM. We'll learn about this as we go ahead in the future chapters. So ROM stands for read-only memory. Don't need to know this for this chapter for now. Then we have CPU, the central processing unit, microprocessor, which allows for the execution of instructions from programs. NIC, network interface card, allows a device to connect to a network such as the internet. It has a unique MAC address, which is media access control address. You learn about this in the future, so just calm down, okay? Graphics card allows circuit board that allows graphical data to be sent to a visual display unit. So you see how YouTube has all those different resolutions, right? 480 pixels, 360 pixels, then was it 1K or so? 1080 pixels and all that, 4K. Those are the graphics that you see. How clear is it, right? So this is divided by your graphics card. Sound card, basically, as the name says, integrated circuit board that provides the computer with the ability to produce sounds. Then internal storage. Now, internal storage such as hard disk drive or solid state drive. Now, your computer or your laptop or any device you're using can either have this, or there are other ones that we'll look at later that act as additional data storage to RAM and ROM. So now notice that memory, and storage. So like ROM, RAM, and this internal storage are all the things that our computer uses to store data or memory, right? You'll learn about this, so don't worry. Then external are the easiest. You have your printer, your monitor, your mouse, your plotter, keyboard, and your camera, and other ones as well. Now, that was for hardware. Now, when we move on to software, now software is where you have to pay a little bit attention. Software is the general term used for programs. Let me highlight this. Programs that control the computer. I can't. Okay. Yeah. Programs that control the computer system and process data. Software can be applications or system software. So you have your software, okay? Software. Now, software of two types. One, two. Now, the first one, it's a system. We can have system software and we can have application software. And now we'll look at these below. So there we go. Number one, application software. It provides the services that the user requires to solve a particular task. Okay, and system softwares is designed to provide a platform on which all other softwares can run. Examples of both of them include here. So now you see, let's say that you have to draft up a letter to your principal, okay? And you're going to use Microsoft Word for that. Now, Microsoft Word becomes your application software because it allows you, the user, to solve a particular task. What is your task? Writing a letter. But system software is designed to provide a platform for all these other softwares, such as these word processors, spreadsheet, and all the ones listed here to be run on your computer. So that's what system software does, and that's what application software does. So examples of application software and system software, I'm not going to read particular ones, but okay. So we have word processor, we have spreadsheets such as, so we use Word over here, we use Excel here, database management, we use Access here for examples. Now, please make sure that when they ask you to give examples of application software, you don't go and say Word document, Excel, Access 2020 or 2021. No, you're not supposed to say that. You have to mention word processor and not Microsoft Word, spreadsheet and not Excel, DBMS or data management and all that. Not particular apps that you use to do those tasks. Okay, please make sure of that. Then control and management or measurement, audio or video editor. Now you have different softwares that you use to do this task. You have graphics editor as well, CAD, which stands for computer aided design 7 here. Then we have apps or applications that we use normally, right? Now, these are very general. But when you come to system software, right? Now, these are only five. Now, you can have more application software that you can use. For example, you can have security softwares and all that. But when you come to system software, these are particular ones that you need to know. So you have one, two, three, 4, and 5. These are the five system softwares that you need to know. So let's look at the first one, the compiler. Now, this software translates program written in high level language code into machine code that can be run on a computer. So from a high level to a machine level language, so high level such as Python codes and all that, converted to machine code, zeros and ones, so that it can be run on a computer. Now, linker, it takes a number of object files and combines them into a single program. Example, combines modules. So as the name suggests, it links objects and files together, okay? Device drivers, software that enable one or more devices to communicate with an operating system. For example, your printer. Now, your computer has a device driver and your printer probably has a device driver, and they're communicating with each other on what they are supposed to do. So once an instruction is given from here to there, they are communicated with each other through the device drivers. Then operating system, the software that runs in the background that manages all basic functions such as input, output, loading, running, programs, error handling, and all that. For example, the operating system we used for this one is Windows. You could be using MacBook or iOS, sorry, or Linux, Linux. So we have different operating softwares as well that different computers use. Utilities are software designed to do a specific task to maintain and control the computer's resources. Now, if you see antivirus softwares, right, such as Quick Kill and all those, now these fall under utilities, okay, because they control the computer's resources. So antivirus, disk repair, security, and all that. Analog and digital data. Now, please pay focus over here because as you go to chapter 5 where microprocessors and all are there, this really helps you because this is what you'll be mainly talking about and using. So computers can only understand data that is in the binary format, that is zeros and ones. This is referred to as digital data, which is in contrast to analog data found in real world, which uses continuous data. So now you can use this to remember binary and digital. Now I know this will be a bit long video, but the chapter is also long, so please watch till the end. So let's say this is how it is. So 1, 2. Now let's say that this is 0 and 1. So you can see that it's always either going to be 1 or it will drop down, it will be 0, or it will go up, it will be 1, drop down, or it will be 0. So now this is digital because it has only two values. But if it were to be analog, then you notice fluctuations and all that thing. So this becomes analog. Okay, analog. Okay, I haven't drawn it perfect. Yeah. So analog data is physical data that is continuous and not discrete in nature. It can have infinite number of values, so it can go infinitely up or down. Okay, let me just phrase that. Digital data is written in binary formats of ones and zeros. The data is discrete and only has specific values. The accuracy of digital data depends on how many bits are used to represent the data values. If analog data needs to be sent to a computer, it will first be converted to a digital data. If a computer needs to control a device, such an actuator or a motor, then the digital data will be converted to an analog form. Very confusing, I'll be honest. So let me just explain this. Okay. So a computer, okay, can only understand digital data, but an analog, such a motor, okay, a motor can only understand analog data. Now, how are they going to communicate with each other when this guy only understands digital data, this guy only understands analog data? Now, this is where these devices come in. Okay, when I want to convert from analog to digital, I use ADC, and when I want to convert from digital data to analog, I use DAC. Very simple. Analog to digital converter, digital to analog converter. Very simple. So just take ADC and DAC to remember it. Okay, very simple. Let's move on. Now, main components of computer systems. First, we have the central processing unit. Now, the CPU is a computer component that interprets. Okay, let me even highlight that interprets and executes command from computer hardware and software. It is usually part of the motherboard. The main components of the CPU are the control unit and the arithmetic logic unit, and it's often referred to as the microprocessor. It's not only these two components that we have other ones such as, I think, is it the clock or the time or something related to that? I can't really remember it. But yeah, we have more components of the CPU as well, not just limited to these two. Then we have internal memory and backing storage. Now RAM and ROM are internal memory. So it's very important to know the difference between RAM and ROM. Okay. So I think this table does it. Okay. So now the data in the RAM, okay. Let me change the color. Let's use red, I guess. Okay. So now data in the RAM, it's temporary data, so it can be changed. Whereas the data in the ROM, it's permanent data and it cannot be changed. This means that I'll use ROM for what? I'll use it to store my BIOS data or my startup data. So when you start your laptop or your computer, right? You see the screen that comes in the boot up that's happening. I'll store my ROM data in of ROM over there. Whereas I'm working on this file right now. I've opened this particular file. Okay. Now I'll save this file on RAM because I'm temporarily using it. Then we have volatile and non-volatile. Volatile data means that if I'm using my laptop and suddenly my battery finishes and then it turns off, whatever data I had over here, it will be lost. But non-volatile means that the data will still be there even if there's a power off or this shuts down. Now that makes sense, right? Because if I have boot up data stored in my room, you don't expect it to be lost, because if it's lost, how is my computer ever going to start, right? Now, because of that, this means that the data in ROM can only be read. You cannot change it. But since the data in RAM is temporary, then it can be written and read as well. So RAM stores data files, part of operating system currently in use. This shows BIOS, both input and output system, and other startup data. Can be increased in size to increase the computer's performance. Okay. Then we have input and output devices. Input devices, very simple. Input devices allow data to be inputted or entered into a computer either manually or automatically. You'll learn about this direct data entry and this later in the coming chapters. And output data, as the name shows, it outputs or allows the result of a computer processing to be shown in a human readable form. Okay. Note some devices can be both input and output, such as touchscreen. For example, this touchscreen that I'm using, it's both an input because I'm able to input this, but while I'm inputting this, I'm able to see it as well. So it's both an input and output device. Now they are covered more in chapter 2, so when a video comes out on that, please make sure to watch it. And also, if you haven't liked this video yet, please do that, comment, and subscribe as well if you haven't. Then backing storage. So now, although this RAM and ROM are there, data to be kept permanently, which can also be altered, unlike the ROM, is stored on the backing storage. Backing storage are generally hard disk drive or solid state drives. Okay. Um, blah blah blah, I don't need to remember this. Okay, backing storages are usually solid state in modern computers because this SSD has far more advantages. It's better because it can store more data, it has less moving parts, it's faster and all that. Okay, but whilst we have SSD, it can also be in the form of a hard disk, magnetic, or Blu-ray disc. So now this Blu-ray disc forms a part of optical. So now we have three. Okay, we have HDD, hard disk drive, SSD, and then we have optical. So now under optical we have Blu-ray, we have DVD, then we have CD, which we'll look at later. Okay, now data access is slower than RAM or ROM, but backing storage is usually considered larger. Yeah, so the data stored in backing storages such as this or this is usually far more than RAM and ROM. Okay, the cost per byte of storage is much blah blah blah. Okay, then we come to operating systems. An operating system is a type of software. Now see, it's a type of software. Which type of software? It's a system software, right? If you remember carefully, as we just went over it somewhat 2-3 minutes ago, which enables a computer system to function and allow the user to communicate with the computer by doing all these tasks. I'm not going to read them just for time purposes. So now, user interface. Okay, so for IGCSE ICT, you need to know CLI, GUI, DB, just dialogue based, and then gesture based. You need to know the advantages and disadvantages. Now a tip that they have given us, that a graphical user interface, right? For example, the one I'm using, for example, this is called a WIMP. Okay, whoops, not here. This wait, where am I going? Sorry, just to give me a second. Now this is called a WIMP. Why? Because W stands for Windows, icons, then I stands for icons, M for menus, and P for pointing. So now this thing has all these options, right? This particular interface. But when we look at other interfaces such as CLI, I don't have icons, I don't have menus, I don't have pointing, and I don't have windows. So this is what makes GUI special and better. So I'm going to see. Okay, so we have this left and then this. Okay, let's wrap this up really fast. So where are we going? Okay, so let me just read this quickly. So CLI requires the user to type in instructions and in an exact format. It is slow, error prone, and commands need to be learned. However, the user is in direct communication with the computer. Now this is what CLI looks like. So I'm going to open command prompt. Now this is what a CLI, wait, did I not open? Yeah. So now if they show you an image of this and they ask you what kind of interface is this? This is CLI, command line interface. Now in command line interface, you need to learn all the programming and all the codes. They are faster if you are an expert. If you make even a small tiny grammatical error, a mistake in typing, or it can ruin your code and all that thing, right? Then GUI, basically the one that we use on laptops and all, using icons and all that. Dialogue based, so it's just like you're giving a dialogue. You say a dialogue like, hey Alexa, turn off the lights. So now you're giving a dialogue and now the computer is doing the action for you. Gesture based, For example, you're just sitting and you have cameras looking at you. When you raise your hand and then you twist it in a particular way or do a particular gesture, the computer will recognize your hand movement and know that since it has your this movement is pre-recorded and saved in the computer that, oh, whenever I do this, then this means I have to turn off the light. So when the computer motion sensors sense that you have done this, then it will turn off the light, pick up the movement, and do the action that's it's supposed to do. That's for that. Then let's move on to type of computers. Now, this is something we all already know. So we have desktop computers and mobile computers. Mobiles, we have what? Laptops, smartphones, tablet or pamphlet, which you're all familiar with, but let's just go over it really quickly. Now, desktops, they are not portable because you have to put them at one place and use them, but they are less expensive than laptops and other this thing, uh, because they are usually more powerful because for the same cost, because you can change them, you can really upgrade them more easily because they are kept in one place, and that's their specialty as well. The advantage that they can be upgraded more easily. They have more stable internet connections since they are used wired. So now computers, you put wire for their power source, wire for the internet on, and also they have more stable internet and a continuous power supply and all. For laptops, I'll just really quickly read them because this is something you all already know and just need to know and not really like focus too much. So laptops are lightweight, low power consumptions, no trailing wires, takes up less room, it's portable, it's easy to work with multimedia systems, similar advantage to tablet, but they are often a bit bulkier. Smartphones, small, easy to carry, portable, connects to cellular Wi-Fi network, long battery life, small screen size. It has a small keyboard, so it can be difficult to use. It has relatively small memories than laptops and slower data transfer rates. Then tablet or pamphlet, similar features to a smartphone but a bit larger, can be used with much larger keyboards built, so virtual keyboards which are a bit better, slowly taking slowly taking over from laptops as the preferred portable computing devices. They have similar or better performance. So yeah, basically people are now preferring iPads and laptop tablets and all that over laptops, but there are people that also prefer hybrids. For example, me, I use a hybrid laptop. So now this is both like a tab for me and a laptop for me. So I can use both of them together. But not something that's in your syllabus, so don't worry. Now, last but not the least, emerging technologies. Now, we need to know three of them. One, two, and three. Um, yeah, sorry. So now it will be two and three because this two and three are part of this. Okay, sorry. So artificial intelligence is a machine or application which carries out a task that requires some degree of intelligence. There are a number of positive aspects of AI: increase in safety, quality, faster development, autonomous vehicles. Then negatives are it can lead to job losses, unemployment, and de-skilling. We can become over dependent on technology. Then we have the suspicion that machines and AI will take over in the future. And then extended reality refers to the combination of both real and virtual environment, and the most common examples are augmented reality and virtual reality. Now you need to know the whole chapter really well because trust me, this is like the foundation of ICT. So I think once we do this table, you should be fine with the advantages, disadvantages, and all that. So, in augmented reality, the user experiences relationship between digital and physical world. So now, have you played the game Pokemon Go, where you catch Pokemons in real life and all that? So that is an example of augmented reality. The user is not isolated from the real world and can still interact and see what is in front of them. So you can see what is in front of you. You're not immersed into the augmented reality. The user can experience the augmented reality through special goggles or via a smartphone or a tablet as well. Virtual data and objects are overlaid. So you have your real world, you have virtual objects on kept on top of it. So this is just like the Apple. I don't even know the product name to be honest. That thing that you wear on your eyes. Come on, how can I forget? Okay, yeah, that thing. Oh god. Okay, once I remember it, I'll put in the comment. So that thing where you see everything happening, how can I remember? How can I forget? Never mind, forget that. Then virtual reality. It's when the user is completely in the virtual world, completely immersed in an artificial computer generated environment away from the real world. The user is fully immersed. The user needs to wear a VR headset, which gives a 360 view of the virtual environment. You also need sometimes motion sensors. You can need speakers, microphones, and all. Can be used in medicine or surgery, construction, education, and military applications. And yeah, that's all with this chapter. I'll see you in the next chapter really soon. Till then, make sure to like, share, and subscribe. I'll see you in the next video. Till then, tada bye. Yeah, this video is really long. Sorry. Bye.